first of all do a step back into the past about how data management started. First of all, we all know in the 90s it was the data warehouse. The data warehouse was created as an abstraction layer between the data sources and the users. And why did people do that? Well, first of all, they wanted to bring the data together. And not only because the data was heterogeneous, that was one reason, but the second reason was all doing queries on these data sources caused also performance issues that these transactional systems couldn't do their work. And what they also wanted to do is create a high performance environment, or a good performance environment with high user satisfaction to answer questions. And that's what the data warehouse is still today, to answer questions people know what they want to ask. So it's basically about, your questions already on the data. All you have to do is now build in those aggregations, build in those schemas to answer these questions. So it's actually very good when it comes to operational analytics. But over time, people notice, well, I would like to, start adding different types of data. Data has grown. You had like internet data coming in, you wanted to query, and operational data warehouse was not able to, deliver queries on these large amounts of data in a very performant way. Plus, also, if you have a data lake, you would like to also do data science, machine learning. You also want to find golden nuggets in the data, but if you try to create pre-schemas, you will not be able to achieve these goals. So the data lake was created. However, what happened is people didn't do very good labeling and tagging on these data lakes. And then the data lake became more or less to a data swamp. And Gartner today even says that a lot of data lake projects do fail because there is a high expectation towards it, but nobody has done a real good job in making sure that this data lake is usable for the so-called query engines or MPP engines like Impala, or new ones are like Spark, Dremio, or Presto Trino. And so what else is happening in the market? Well, basically with the data lake, you've answered certain questions, but business is becoming increasingly demanding when it comes to achieve digital transformation by achieving faster integration of data. Moving large sets of data from A to B is a challenge. You usually need an ETL tool, or you need some kind of a data transport tool. If you want to do real-time analytics, you always have to make sure you get the data together. So that's also a challenge. And they're also looking for a better data discovery process. So what IT tries to do, they try to get all that data into one single repository across all different types of systems. We have a lot of that situation where we see a data warehouse, and then they want to bring all that data warehouse data into a data lake, or they try to create something like a data lakehouse. But that is also challenging because usually the formats they get from those certain systems are very cumbersome. Then it takes time until the data is available. And then you start adding more types of data. And doing a singular repository is, in our opinion, not always the right way to move forward. You can, of course, try to consolidate, but it's not going to get you the speed and agility for driving digital transformation in an agile and fast way. That's why we think the logical data approach is the best approach for this. And we'll talk a little bit about why that is. So why is logical data very important? Okay, as we talked about the different types of data silos, okay, for real-time analytics, you're using streaming analytics. For data exploration, data science, maybe machine learning, you're using a data lake or an on-premise Hadoop system. A lot of companies still have a lot of Hadoop systems on-premise. Then you have graph databases like TigerGraph or Neo4j. Then you even have NoSQL databases like Mongo or Couchbase. And then you have all these traditional reporting and analysis systems for data mining or standard reporting. And that causes silos, point-to-point silos. So for Kafka, you have a certain front end. For the data lake, you're starting using certain front end. And every single of these silos have their own language to approach on. And you can't, and then you start creating a so-called, we call it a spaghetti architecture, where you start connecting things from the front end, and nobody really can get agility out of such a siloed approach. And this basically also consolidates in when we talk about the so-called anti-gravity, anti-gravity issues we see when you try to do a singular approach. First of all, the technology, like I said, you have different types of data sources. You will not be able to consolidate everything in one data source, because simply the world has become very much more heterogeneous as it was maybe 10 or 15 years ago. And then you have the challenge towards data residency, geography. You cannot bring your data from EU to the US that easy. You cannot bring it from China to the EU and vice versa. And then we're talking about data ownership. It basically means people are responsible for certain data, and they do not allow this data to be delivered somewhere else. So these are the so-called, we call them data anti-gravity laws. So I'll talk a little bit about the logical data platform from Denodo. Well, first of all, it's a middle layer. You can see that in the red part in between, the layer number 2, which connects the data logically, not physically. We do not transport data around, with the advantage that it's much more agile and much faster when you would start to transport data in a single repository. And in this middle layer, this combination layer, the Denodo data fabric layer, you start discovering the data, you start transforming the data, you can prepare, improve the data, you can also improve quality. And of course, it's an integration platform. We are in the Gartner quadrant for the data integration. And then this data is prepared in a way that all types of users can access this information, from a single Excel user to a Power BI user to a standard reporting user, but also data science, machine learning user to build data products, which then also can be fed automatically in other types of applications. I have an example where a large customer of ours is using that extensively. Just to talk a little bit the quadrant, as you can see, we are a leader in the Magic Quadrant for data integration tools. The big difference towards the other leaders you see here is we do a logical integration. We do not transport data, with the advantages of the customer satisfaction reports, as you can see here. 4.6 out of 5 customers would recommend Denodo to other customers. And that has something to do with the agility and speed of making data available to the users. And the projects are very short in average. So 62% in under 3 months and 91% in under 6 months. So let's talk about the modern data architecture, and maybe also talking about decentral data architectures. So how does our logical data platform support this? Well, first of all, we want to talk about the logical data fabric. You probably heard that term a lot, and everybody's talking about data mesh today. So I'll be talking about that too, and how we support that. And we will also talk about cloud, multi-cloud, and hybrid cloud approaches. So let's first of all put our attention to the logical data fabric. The data fabric architecture is designed to stitch together historical and current data across multiple data silos to produce a unified view and unified access, a unified security of all data. The TDWI, the Data Warehouse Institute, says it in that way as described here. It is not a data transport. It's connecting data to get a unified access and view towards all data types. And it's also a translator layer for the different silos below. So let's run a little bit through how the architecture looks like. It looks very similar to what I talked about earlier on about the platform. So you have all these different types of data silos below anything. It can be files, IoT, sensors, anything. So you don't have to worry about, can we do this, can we do that? We've proven that we basically can connect any type of data silo. And we build an abstraction layer towards all types of users. As you can see, data science, machine learning, but also BI or BI users, or even mobile or any type of application. In this logical data fabric, we create an abstraction layer, we unify the data, and we create one singular security model. And that's where we are extremely strong. We see that a lot when it comes around data democratization, is where a lot of corporations struggle with, because the data silos below do not have a very good security concept. What then IT does, they just lock it up, first of all, or try to lock it up as good as it can to follow governance and regulations. And then the users constantly have to run to the IT and ask for access to this data. Our security is role-based access model. That's the core concept, but it is also exception-based. You can deliver also KI and AI possibilities in there. And also you can get those exceptions in. For instance, a user A, let's say, is allowed to access certain types of data on Monday and Tuesday, but not this type of data on Wednesday, Thursday, and Friday. And user B can do it vice versa. So it is a very flexible way of delivering security, and it drives data democratization and data literacy, and that's what I talked about in the beginning, towards the users. Maybe some words about the self-service data catalog. It is how we describe it. It is not a data stewardship, or it is not driven to drive data governance. Of course, we have a lineage from the data front end to the core systems, but it is to drive self-service capabilities. It feeds itself out of the logical data fabric, and it feeds itself automatically. So you do not have to build up a strong data catalog project. First of all, the connections are there. It feeds the data, the catalog with metadata, and a big difference also towards other data catalogs, also with content. And that's very important when you want to search on certain types of models and data and what's underlying below that. And like I said, the project is not big because it's an essential part, and it's inside the Denodo platform. So a very flexible approach. And of course, it supports annotations, it supports collaborations, and it also is supported by the unified security system of Denodo. Maybe one more word about the data catalog. If you're an AI machine learning user, what you can also do is build your models in your notebook, and you can actually put that model right into the Denodo layer, and the data catalog recognizes that model and the acquired data towards it automatically. So it's not a batch process, it's a very automatic process. So this process can be speeded up very quickly, specifically when you want to share your new models and your new machine learning products towards the organization or to other data scientists and other AI machine learning users. Now let's talk about data mesh. I've seen we have a lot of experts here, so maybe for a lot of you, data mesh is nothing new, but maybe I'll just run through it a bit. What is the concept behind it? Well, first of all, it's a new architectural paradigm to manage data proposed by a consultant called Zhamak Dehghani from the US. And it's talking about moving from a centralized data infrastructure managed by one singular team to a distributed organization. And when we call this distributed organization, it's moving it to so-called autonomous units or domains. You can also organize it in a business unit way. And why do people do this? Well, first of all, we always had that problem of this translation from the IT to the business users. The business users knew their data usually better than the IT, but the IT, of course, provided the infrastructure for it. But it's moving this translation problem from, that the users constantly have to talk to IT, away to moving it into the domains, moving it to the area where the users know the data the best. However, what that means is also they're responsible for the data. They have to take the stewardship. They have to make sure the data is valid, they're reliable, and it's trusted. And it's not only reliable, trusted, and useful for their own domain, it has to be reliable and trusted for the whole organization, so that the data products created are easy discoverable and understandable and accessible to the rest of the organization. So Forbes says, to wrap this up, data mesh allows data sources to remain distributed and controlled by different organizations, but must be accessible to a centralized application. So here we're talking about the Denodo logical data mesh platform. Like you said, it can be used for a lot of different architectural concepts. Here you see these data domains below. These data domains can be basically use the same data silos. So data domain A uses the same data warehouse as data domain B and C. But it, of course, can be different types of data silos. And in the logical data mesh, we then, of course, connect these domains together, build the abstraction layer, unified data, security, and make it accessible towards the whole organization. And also the data domains can control the security and who gets to use what types of data inside the organization. And that's why I built a little bit more detailed view on that, on the Denodo data platform for data mesh. You can see the data sources. You create base views on all these data sources, and then you start standardizing the views. That's very important if you want to do data democratization and data literacy. And it also drives the same language when it comes about using the data throughout the whole organization. And then the domains are starting to be responsible for the data quality. They're responsible for the governance of the data in their own business use or their own data domain use, and then making it accessible towards the whole organization. So my last concept is around multi-cloud. I like to call it more hybrid cloud or hybrid multi-cloud approach. Forrester says CIOs face the challenge of multi-cloud and of developing an effective strategy to understand the manage of mix of cloud resources. First of all, it has something to do around business dependency, making sure that they're not too dependent on one cloud vendor. And it's about getting the best services from each cloud vendor and from each hyperscaler. We know some services of one cloud vendor are better than services of another cloud vendor. And the CIOs want to make sure that they get the best services to the best price from all these hyperscalers, with, of course, the challenge that the data is then separated in different areas. Here, let's say example, AWS, GCP, and Azure. And I also want to bring it together with my data on premise. And you will have data on premise. I know in a lot of regions and a lot of corporations, there are certain data types they do not want to bring into the cloud. We have that a lot. So you will always have some types of data in your own data center on premise. So how does a multi-cloud data mesh work together? Well, this is no surprise. We stitch together the data, all the different types of data from the different hyperscaler, also combine it with on-premise data, and then deliver the abstraction layer, unified data, the security layer for all these data, and deliver you a universal access. And we have a lot of companies that do this nowadays, because like I said, the world is heterogeneous, the world is multi-cloud, and I also have different types of data silos on my on-premise world. And we already talked about the advantages of the self-service data catalog. Maybe just to talk a little bit about network optimization, because that's a nice feature additionally to it if you want to drive your journey towards the cloud. As you can see, we have a Denodo in the cloud. By the way, we're available as a service on all three hyperscalers. Then you have your Denodo on premise. And then you can see Denodo is querying 25,900 rows out of the cloud. And what it does, it optimizes that query and reduces the results down to 77 rows. First of all, for network optimization, but also lowers the cost of network. Basically, you know the word egress costs, so it's also a cost reduction platform. And then even with the data you use on premise, you can reduce it or keep it at 77 rows or maybe even lower. That's possible to do it that way too. And here you can see some examples around data residency. As we talked about, you have data in Asia or in EMEA, in APAC, in EMEA, and the US. You're not allowed to transport the data, but we know there are windows and possibilities to at least deliver results of that data through the world. And with the low network challenges or the low network costs, it is very cheap and a very efficient way of collaborating on data if you are a multinational company. I'm not going to talk too much about Logitech here, but Logitech is an example that said how successful Denodo supported them on their journey into the cloud. We have a lot of companies that use this when they want to go into the cloud, specifically when it comes also to replatforming, making the data in the cloud accessible also to other users without having disruption. I talked about APIs. I talked about, we always hear the wording around, okay, is that performant? Can that even be fast? Will you even be able to deliver large amounts of data from different types of silos to with very complex queries to a large amount of users? Yes, we can. I'm just going to pick out Intel here. Intel is probably our worldwide largest customer. They're where 200,000 users, basically 100,000 internal, they have around 100,000 employees, and 100,000 external vendors, customers, use Denodo as a data fabric, as a data fabric layer towards all types of data services and collaboration data services between the external and the internal applications. Over 2,000 applications are being used currently. So over 2,000 applications are being fed over 300 data sources. And here you can see 2 million queries a day are being put off into the system. And they're been using it now for 7 years. And so far, not 1% of downtime, 0% downtime. And Intel itself says, this is a concept of connecting data has shown them that they can now deliver data 90% faster. So my last slide, the key takeaways. We think Denodo is an essential part and a key technology when building a modern data architecture. And Gartner, you can see that in their papers and their analyst reports see that too, is even if you have a central data lake, even if you have a data lakehouse and you think about centralization, you will always need data as a security layer, abstraction layer, self-service layer, data literacy layer to simplify the access towards these different types of data silos. And it delivers flexibility and agility to reduce time to deliver data. And this is also what we see in Gartner peer reports for businesses up to 10 times the data is delivered faster. And with our logic approach, we also hide the complexity of different types of users above and also the changing data infrastructure below. We have a lot of companies that use Denodo also to support replatforming. You have a data warehouse right now on premise, you want to bring in the cloud, you can always still use the on-premise data warehouse until you finally have brought all the data into the cloud. You plug in the cloud, plug out the premise, and you will see no user disruption above because they're all accessing that abstraction layer of Denodo. And we support and introduce, and it will help you introduce new types of technologies, formats, and protocols without causing user disruption, as I just mentioned in the earlier sentence. So I'm done, and I'm open for